If you're preparing for the AI-900 exam, you've likely seen supervised, unsupervised, and reinforcement learning grouped together. They are easy to mix up at first, but once you see the patterns behind them, you'll be able to tell them apart instantly. Machine learning is simply a way for computers to find patterns in data without a human writing out every single rule step by step. Instead of rigid code, we feed data to a model and let it learn from examples. The AI-900 exam focuses heavily on your ability to look at a business problem and decide which type of learning is the right fit for the job. The type of learning depends entirely on the data. Does the machine have a list of correct answers to study? Is it looking at raw, unorganized data? Or is it learning through trial and error, like a player in a game? Understanding how supervised, unsupervised, and reinforcement learning handle that data is the primary key to navigating the machine learning portion of the exam. Supervised learning means learning with labeled data. Labeled data simply means each input comes with the correct output, like question and answer pairs. You can imagine a huge Excel sheet where one column has features and another column has the correct answer. For example, think about predicting house prices. You have many past house sales with details like size, location, number of rooms, and the actual sale price. Those sale prices are labels, the correct answers. The model looks at many such examples and learns to predict the price for a new house. Another example is email spam detection. You train the model on thousands of emails already marked as spam or not spam. Each email has a label saying whether it is spam. The model learns patterns and then can label new emails as spam or not spam. It's like a student learning with a teacher and an answer key. The teacher provides the questions and the answers at the same time, so the student can eventually learn to solve similar problems on their own. Use supervised learning when you have historical data with known outcomes, and you need to predict a category or a number. Unsupervised learning is different because there are no labels or correct answers attached to the data. The machine is given raw inputs and told to find the structure on its own. This is used for clustering, where the system acts as an automatic organizer. Imagine a store with thousands of customers. The model can group them based on similar buying habits, even if we haven't defined those groups ourselves. This allows businesses to see natural segments in their data, helping them understand how different types of visitors behave on their website. Think of a student with a box of mixed objects. No one says these are toys or these are tools, but the student naturally groups them together based on their shape or color. Choose unsupervised learning when you don't have the answers, but you need to discover natural groupings or identify unusual patterns in your data. Then there is reinforcement learning, where an agent, think of it as a player in a game, learns by taking actions in an environment and seeing what happens. The model learns through a feedback loop of rewards and penalties. Good actions earn a high score, while bad actions earn a penalty. This is how an AI learns to play games like checkers. It tries thousands of moves, learns which ones lead to a win, and develops a strategy to maximize its reward over time. It's the same logic used to teach a self-driving car how to change lanes safely. It's like training a pet dog. If the dog does something right, it gets a treat, a reward. If it does something wrong, it gets no treat, a penalty. Eventually, the dog learns which actions bring the best results. Reinforcement learning is the right choice when you need a system to learn a sequence of decisions to reach a long-term goal. Now, let's put these three side by side to see exactly how they differ across the data, the goal, and the feedback. Supervised learning uses labeled data, unsupervised uses unlabeled data, and reinforcement relies on interactions. Their goals differ too, predicting an output, discovering patterns, or maximizing a reward. Finally, feedback varies, checking against labels, organizing data, or reacting to rewards and penalties. You see these working together frequently. Netflix uses supervised learning to predict your movie ratings, but uses unsupervised learning to group you with other users who have similar watching habits. When you read a scenario on the exam, look for these indicators. If you see labels or known answers, it's supervised. If you see no labels or discovering groups, it's unsupervised. If you see rewards or penalties, it's reinforcement. Linking these indicators to the learning types is the most direct way to correctly identify the right model in a business scenario. Let's test this out with 3 realistic exam questions. Question 1. A company has house sales with known prices. The indicator, known prices, means we have labels, making this supervised learning. Question 2. A store wants to group customers based on buying behavior, but has no labels. This no labels indicator means it's unsupervised learning. Question 3. A robot learns to walk by getting a reward when it stays balanced. Learning with a reward system is always reinforcement learning. If you found this helpful, I've put an AI-900 study guide and mock tests in the description and the pinned comment below. Make sure to subscribe for the full course. In our next video, we'll look at the specific Azure AI services that appear on the exam. Mastering these fundamentals is the first step toward building real-world AI solutions on Azure. See you in the next one.